Today we are going to talk about important oncogenes and associated tumors. Well, I think it's difficult for every student to learn about all the oncogenes, proto-oncogenes, and associations. Well, I will make it more easier to learn it. Well, let's start. Well, there's the first one is growth factor, platelet-derived growth factor, and or expression of it leads to astrocytoma. Well, I will mark it by yellow color for overexpression and autocrine loop. Only one growth factor there is, and it would be difficult to forget it. Yeah, and astrocytoma. Next is growth factor receptors. Next are growth factor receptors. Well, there are three. Epidermal growth factor receptor. I will mark them by mutations, types of mutations. Amplification, it would be green. Next, amplifications, nuclear regulators, and MIC, and L-MIC, and neuroblastoma. L would be lung carcinoma. Next amplification is CDK, cyclic dependent kinase, which leads to melanoma, second cause of melanoma, one of the causes of melanoma. Well, the other cause of melanoma is RAS gene family. This is not, this occurs due to point mutation. Well, point mutations would be marked by blue, red family, KIT family, and RAS gene family. They are all occur by point mutations. And translocations, well, translocations, it is kind of associated with some kind of transgender movement and so on. Well, I can link it with color of rainbow. Red, yellow, green, blue, and so on. Blue, green, yellow, and red. Here also red. They should be yellow color. Well, that's all. Let's begin our learning session. Well, first one is platelet-derived growth factor. It is growth factor, and when it's a lot, I mean, there is a lot of growth factors, cell begins to divide. Well, here's cell, and P, T, F, G, F, and astrocytoma. It works by autocrine loop. Next is our ERBB gene, HER2/neu, epidermal growth factor receptor. And it would be marked by green color, as I said. It's a receptor, yeah. And a mutation in this overexpression of this receptor can lead to breast cancer. And green color indicates that here is amplification type of mutation. Next is blue color, and it's due to point mutation. Point mutation occurs in three types of functioning molecules. There are growth factor receptors, signal transducers. Okay, first one is red. Red gene is when red gene is mutated, patient can have multiple endocrine neoplasia type 2A, type 2B, men 2A or B, or sporadic cases of medullary thyroid carcinoma. Next receptor which is mutated is KIT, KIT, and gastrointestinal stromal tumor. GI, stromal tumor. It is also it's also made by point mutation, blue color. Yeah. Next point mutation is done by signal transducers. You know, there is a device called ultrasound, and there is a part of the ultrasound machine which is called transducer, which creates ultrasound beam. Yeah, like that. I'll make it not blue. I'll make it dark blue. RAS gene family. It works by GTP proteins, GTP binding proteins. Well, there are the mutation in the RAS gene family is caused by no, it leads to melanoma, carcinoma, and lymphoma. Well, that's all. Point mutation, and next is translocation. Which leads to CML and ALL. It's also transducer. That's why I will make it like a cardiac transducer. I will make it look like cardiac transducer, which makes sound. Yep. And ABL mutation, translocation in ABL gene. ABL is from 9 to 22, and it leads to chronic myeloid leukemia, CML, and ALL, sometimes ALL. And there are transcription factors which occur by translocation. It is first transcription factor, which mutates due to translocation, is C. Let's make it different color. CMYC, which leads to Burkitt lymphoma. Other genes, which transcription factors, which N and L, MYC. Mutation occurs due to point mutation, and N, neuroblastoma, and L, lung adenocarcinoma, lung cancer. Well, there are two cell cycle regulators, CCND1, cyclin-dependent 1, cyclin 1, which leads to mantle cell lymphoma. It occurs also by translocation. I'll make it look like a bicycle or motorcycle. Cyclin D1. Well, cyclin D1 or CCND, which leads to mantle cell lymphoma. Mantle cell lymphoma. And there are translocation from, well, sorry, I forgot to mention CMYC mutation translocation, and CMYC is 8 to 14. 8 to 14. 11 to 14 is mantle cell lymphoma. And the last one, CDKN, CDK4, second dependent kinase. It's made by amplification. We can add it here. Amplification, melanoma also. CDK plus amplification and point mutation, RAS and CDK. That's all.